For said work.
Okay, so doing your practice work is essentially studying. Maturity.
I am very mature.
Brian, that is.
So, oh yeah, if you want a graphing calculator, this would be good.
I don't like.
Oh, I forgot to charge the gun. Oh no. Brian came. I got it. Thank you. This isn't a hack, but I know it's annoying.
So, remember how we were making lists in L1, L2, and then we were using the calc menu of lists to do a one variable statistics, and we ran it with L1 and L2, and we found out all those data values from that? My wife was doing that exact work last night for her college statistics course that she's taking for her master's. So, the work that we're doing right now is important and does tie to much bigger mathematical concepts, because when we analyze data sets, we use that function a lot. So, I think we stopped right with these guys, right? And we had talked about how these, we would use our quadratic equation because we have coefficients on the x squared, and or these numbers just don't really look like they're going to work well together. And dependent on the shift that it's had, it might even just have no solution, so it's not solvable. So if we look here, we need x squared minus 8x plus 12, and we want to talk about what method we would choose to solve it. I immediately think about, is it factorable? Because that would be the easiest option if it is. So in your head, especially when it just starts with x squared, think, are there two values that will sum to negative 8 and have a product of positive 12?
Yeah.
6 and 2. So if I use negative 2 and negative 6, I can think of that quickly, and faster than it takes to even remember the quadratic equation, we could find our solutions of x equal to positive 2 or positive 6. Or slash and.
Wait.
Really it's and.
Can
But
I ask why you put the signs?
because what will make that 0? This equals 0. For this product to make 0,
Okay.
one of them has to
Oh,
be
yeah,
0.
I get you. All right.
Positive 2 makes this 0.
Okay.
Positive 6 makes that 0.
Coolio. Thanks.
So factoring, honestly, is easiest here. And one of the ways we can identify that we should check the factoring, if you don't have an A value, or if your A value is 1, I guess we'll go ahead and say, think about factoring first. Aside from that, if your A value is not 1, can you factor out the A value and then able to factor it to the two binomials? And if none of that works, then we start thinking about, can we solve it using quadratic? And if it was able to be solved algebraically, it should have been easier than this. Any questions on choosing a method? The quadratic will always work, whereas the other methods not always, but sometimes they're easier. So go ahead and look at the back. Thank you guys, by the way, for helping with that search that we just did.
I'm still like searching mode.
I'm nervous. Like I mean, it can be replaced, but it's expensive.
Yeah.
So.
And it's also stupid. Someone else's fault.
So we have an equation here, not in standard form. They say start with the original equation, but we can skip that stuff if we want to. If we want to go immediately to our quadratic form, what would I do on both sides to get to quadratic form? Caleb?
You add 5.
We would add 5, which makes my equation 2x squared minus 3x plus 5 equal to 0. Now it asks us to evaluate our discriminant to determine how many equations are there. So remember, your discriminant is what? I was about to say, for once, she didn't raise her hand.
I'm sorry.
Carmen, you said it is?
B squared minus 4AC squared. I'm sorry.
Now, where I see people make mistakes and mix formulas up. What's the formula that I use to find my axis of symmetry? Brian?
Is that like B squared over like 2A?
Close.
Oh, 2B. Oh, it's negative. There's a negative in this. Isn't it negative b over, wait, negative squared over 2a? Okay.
No, not negative b squared.
Oh,
It's
negative
just
b,
negative b
okay.
over 2a.
Yeah.
So be careful you don't
do
mix.
the first thing and then you just add the discriminant onto it.
So remember, your quadratic formula is essentially a combination of your axis of symmetry and the discriminant. Except then we square root your discriminant and it's plus or minus. But if you think about that axis of symmetry, if that is at negative b over 2a, think about this. My quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So what the quadratic formula is doing is combining the axis of symmetry and your discriminant to find those solution values. So if we look at our discriminant here, our b is negative 3, so b squared is going to be negative 3 squared, 9, minus 4 times 2 times 5, and that's going to give me, yeah, we don't even really have to think that hard. Is my answer positive, negative, or 0? It's going to be negative. We don't really care what the negative value is. I mean, we will if I use the quadratic. So it's nice to go ahead and think about this is actually negative 31. So if I go to use the quadratic, I actually already know what goes in the square root, but crap, I can't take the square root of a negative. So draw a conclusion. What do we conclude here since my discriminant is a negative value? Emma, say it louder. There are no solutions. I mean, a lot of times we use the empty set for no solutions, which is not 0. It is saying the lack of any value. So 0 means nothing, right? There are no pizzas. There are no dogs. This literally means there's no solution. There's not, like 0 is not the solution. There's no solution. So be careful because some people will say like, oh, 0. Well, that's a number. That's a solution. So you have to use the 0 with the slash to mean empty set.
But it,
What?
for this, you could put 0,
But 0 is not a
but it's
solution.
saying number of solutions.
Okay, so there are no
That's
solutions.
why I was going to say.
Yeah, but saying 0 is dangerous because if you say 0, that could confuse, is 0 a solution or are there no solutions? So that's why I'm just saying be cautious. Yeah. I hate that because on my old software I could just scroll. Okay, try this on your own.
I know we have to use the discriminant or whatever with this, but how do we know what numbers to put into it?
So when we get to standard forms, if I subtract 7 from both sides, and I get to having 6x squared minus 5x minus 7 equal to 0, then these values are really our A, our B, and our C. So C doesn't get used here, but, or sorry, in the axis of symmetry it doesn't get used, but I do use B, A, and C all here because remember, A is your coefficient on your x squared, B is the coefficient on your x, C is your constant. So when we set this up, because remember, we really square root the discriminant. When it comes to solving, this will get square rooted, so if this is negative, it's impossible. So when we think about finding b squared minus 4ac, that's telling me, is it possible to take the square root or not? And if it's not possible, there's no solutions. So I'm going to write the whole thing out just to make sure we all understand where these values come from.
And how do you get to like,
How do I get what?
what the one solution what determines that? Like negative, positive.
The only time there's one solution is when your discriminant, if you flip back to the front of your page, this tells you it is 0. Because 0 only has one square root. Because 0 is neither positive or negative. But every other value has a positive square root and a negative square root. Every positive value, sorry, has 2 square roots. So this becomes 4 times 6, 24 times 7. This is actually going to end up adding, what is it?
Well, bigger than 25. Well, yeah, it's like
193.
So here's all that matters.
Oh, wait. Oh, I did it wrong.
Ah,
I second
Getting
Michelle's
tripped up.
answer.
it is big and positive, so that tells me how many solutions will this have?
Two.
2.
I done diddly screwed up.
What's the significance of big?
Because I didn't want to do it.
bigger than 25? Or just positive?
Just that it's positive. But I know it's going to be a, so what? This is 24. 24 times 7 would be 140. Yeah, 168.
I kind of forgot order.
So this ends up being 193.
Emily, yeah, we forgot order of operation.
Doesn't matter. I just wrote big because I didn't want to do it. So this is now convenient. Is this the end of the notes? Okay, let's go a little bit deeper. This is now convenient because if I want to solve this, let me capture this and get rid of it. Now that we've determined it's got 2 solutions, I should put forth the effort to solve it. Let's use the quadratic formula. And that's going to be radical. Sorry, negative b not squared yet. We square inside. This is what I mean, guys. I've used this a bunch, and it's still tough to remember. But you should, as you're building it, you should kind of be able to see, like, oh, wait, I put that in the wrong place. Your square goes under the square root, which seems kind of dumb. But since we solve all this first, it does not just cancel out. Remember, your square goes in your square root. But now, I don't need to solve this, because we already did. We know that's 193. So when I go to actually do this, we can just plug in my b. The opposite of my b is positive 5. Plus or minus radical 193 all over 2 times 6. Because we already solved our discriminant. And this makes it a ton easier to put into my calculator. Because instead of, having my calculator have to do all this and make sure that I put that all in the right order, all I got to do is when I type this in, here's my advice, because I saw people getting wrong answers yesterday because you didn't group your values. Start a parenthesis for the numerator. When you start your square root, it's going to have a parenthesis, so then you're going to have 2 closed parentheses from the top, and then either evaluate your denominator before you plug it in, or put that itself in its own set of parentheses. Because then it solves the numerator and solves the denominator, and then does the division. I saw people yesterday getting wrong results when they typed in their calculator like this, because this solves the numerator, divides by 2, and then multiplies by 6. Not what we want it to do. That's why we need to group this denominator unless we evaluate it before we ever start. When we plug that into our calculator, our resulting solutions are, did we get it yet?
You want Ryan to?
Hundreds or thousands,
Okay,
whichever.
so 1.6, I guess, and then negative 0.7.
That verification? Yes.
No.
Anybody having issues getting that? Issues typing it in?
I had screwed up on the beginning because I forgot order of operations, so I did the wrong one.
Your calculator, and this goes back to, I was telling the same thing to my wife last night about the TI-83 being a really dumb computer that I was telling you guys. It follows order of operations blindly. Even if you are trying to set this up, if you don't have these parentheses, that's why it goes left to right, does this division, and then does that multiplication. Yeah.
As a testament to how important it is, I put it in with no parentheses, I got 28.
Yeah. It's like, if you don't group it, it does all the math, but it does it in the wrong order because it's not thinking. It can't. It can only do what you tell it. Any questions on these? Do we feel good with using the quadratic formula? The first page of these notes where it talks about how many solutions and the quadratic formula and the discriminant, that's really the most important stuff. So I would like you guys want to pass back the chapter 12 quizzes. If you get to a point where you feel like you're done on this, go ahead and give it back to me and then grab that semester exam. If you have questions on this, now that I'm here, I would love to take your questions. Some of this we may then just talk like as a group. If you need to come see me about high school math stuff, we can talk about that right now. But getting this done is top priority so I can get these graded this weekend. Oh, hey, Stroud. Huh? So how about this? If you want to use your chapter 12 notes, that's fine, but I want to know what you had to use your notes for. So just off to the side, just write use notes or whatever, because I want to know what was difficult. Which apparently putting your name on this is difficult, or people just didn't start.
I just didn't start it.
Did you not start one?
Might have.
Well, I don't have one with your name on it. So does this look familiar?
Mine is blue.
Why no? Why was yours blue?
I don't know.
I thought, oh, that's true. His was like the not copy one. Like, yours was. I got the blue. He got the